Okay, so we said how the last little video there, we kind of finished on part D. And we're saying that the bird and the dragonfly both compete for the fly. And then you're asked to show one example of interdependence. So interdependence is where two living organisms depend on each other. So kind of looking at, I suppose, plants, animals, how they need each other. So I suppose you could maybe look at the grasshopper and the grass and say how the grasshopper needs the grass to feed on and provide protection and shelter. And the grass, it might need the grasshopper then to spread its seeds and so on. Okay. Question 14 then, it's around electricity question. Draw a circle around the symbol for the LED. So the light emitting diode, that is this guy here. A red LED is often used in electrical equipment to tell us something is connected to the power supply or not. Give a reason why it is important to know if a piece of equipment is connected. So obviously, maybe you want to turn it off for energy saving purposes, but the most important thing would be so that you know there's electrical current passing through. So as we say, if you wanted to do some work with it, to fix it or whatever, if the red light was on, that you could turn it off. Give a reason why it's better to use an LED instead of a bulb, and the reason being is that LEDs use far less electricity, so therefore they're more energy saving. The Nobel Prize in Physics was awarded jointly to Samu Akasaki, Hiroshi Amano, and Suji Nakamura for the invention of efficient blue light emitting diodes, which has enabled bright and energy saving white light sources. What was it about their invention that so deserved the prize? So this one is where you can talk about, I suppose, the worth of what they've done. Like, you would have heard of blue light in mobile phones. So a lot of mobile phone screens actually work off this idea of blue light emitting diodes. That's what the screens are working off. So you can say that like the functionality of mobile phones went from, say, a green interface screen into a blue, or into a what we have today. So that kind of helped us move forward. All right, so that's kind of that type of question is one where, you know, your opinion could be an answer in that one. Scientists work by making observation suggestions, setting hypotheses for observations, carrying out the experiments as hypotheses related to the results. So this question now links to your CBA 1. First there, what must you find out about after collecting the data in an experiment? So to see if the answers or the results that you've got support your hypothesis. That's the key thing. Which piece of apparatus can be used to collect and analyze data? So data is like numbers. So like balance, that's a mass balance, meter stick, stopwatch, computer. They'd all be examples of things that could collect data. And then where should scientists report the results of their experiments? So oftentimes they're in scientific journals is where you normally see them. The air design gliders made wings. These wings did not work. What should the designers do next? So if you test the same wings, you're going to get the same result. Design new wings would probably be the ultimate idea. You stop testing wings. I wouldn't say stop testing you because you want to move. Sorry about this now. Sorry, that warning always comes up. And then try to solve a new problem. So I would suggest that they would continue on to test with new wings until they get a new set of wings that work. Okay. Then moving on up here, then which of the following best describes science? Certain information about the known world. That's what you want to do, I suppose. And gathering information about the ancient world. That would be kind of part of it, I suppose. So gathering old information, using new information, and collecting those together. I would suggest the second one there is the most correct answer. What should you do at the end of an experiment if the results do not support your hypothesis? Change your hypothesis or change your apparatus. So you might change your hypothesis possibly, but generally you're trying to prove something. You keep your hypothesis the same. You might repeat the experiment many times, but in that instance you'd repeat it but with differences. Because if you do the exact same experiment, you're going to get the exact same results. And maybe the apparatus that you use, you might need to. So you could pretty make a claim for all three of those ones there. Which the following is the most reliable source of information? So a report in a scientific journal would have gone through a certain number of things. Other ones that could be open to bias, as we've spoken about before. And lastly then, when investigating the effect of a new slimming drug on humans, what is the independent variable? Okay, so remember we have the dependent variable and we have the independent variable. So the dependent variable is the thing that changes as a result. Okay, so the independent variable is the thing that you change. All right, so the new slimming drug is the independent variable, and the dependent variable then would be, does the person lose weight, I suppose, in this case. All right, a few here again. So investigating the effect of, sorry, up there. a new simian drug on humans, what is the dependent variable? So we're saying the measuring the weight loss is the dependent variable. When investigating the effect of a new simian drug on humans, why is it necessary to have two sets of humans? So you have to show, I suppose, that your experiment is proceeding correctly, and you have a control in the experiment. So you have some people who are on the drug, some people who aren't on the drug, so you can compare and contrast them to each other. So to compare those getting the drug with those not getting the drug, that's what you want there to control against them. And the last part of question 15, when investigating the effect of a new simian drug on humans, what factors should be kept the same for both the people? Okay, so the daily dose of medication needs to be kept the same. And I suppose how much sleep they get might have an effect as well. So you try and keep as much things controlled as possible. I'd imagine in this instance, so you're not going to be able to control their sleep or the temperature they live in. You can keep the number of people in each group similar, but that's not really going to, well, I suppose for your results it might help. So the first one and the last one will be the two I'm suggesting there. Lastly then, a student wants to investigate the relationship between the current flowing through a light emitting diode and the difference across the LED. The following diagram of electrical current circuit is not fully complete. Okay, so this is Ohm's law, which we have done there recently. There are 4 additional components that should be added to the circuit shown above. Name 3 of these components. Okay, so you need to put a switch in, you need to put an ammeter in, and that'll have to be in series with the circuit, and you need to put a voltmeter in across the resistor. So the resistor here will be here. Then in the space below, redraw the diagram to include the correct arrangement of it. So what you're going to have is, just a second there, you'll have your battery, your switch, your ammeter, what's the way is that? So there's your diode, there's your resistor, and that's it, I think, is it? Yeah. Then, sorry, just look at that. So you have battery, switch, ammeter. Oh, I forgot my voltmeter. And the voltmeter goes across here. Okay, so across the resistor in series or in parallel. Then you have draw a rough sketch of the graph would look like. So the potential difference is going here, so it's going like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Try and keep them evenly spaced apart. That's not very good by me now. And then the current is like 1, 2, 3, 4, 5, 6, so on. Okay, so that's flying up there to 10, 50. So let's go. So it seems to be kind of going right. What? 0.1 and 2. 0.1, 2, 0.3, 3, 0.4, 3, 0.5, it's like 10 and 50. So your graph is going like that. Well, actually, probably even steeper. So it's very hard to draw this with an angle. So like that. Okay. So forget about that one there. What value of current might flow through the LED if the student had a 6-volt battery across it? What might be the consequence of this? So if we look here, they're saying if they put a 6-volt battery in, so a 6-volt battery is 10 times bigger than this, so the current would be 10 times bigger again, so it would be 500 milliamps, and the consequence would be it would blow or break the LED. Okay, and I'll give an example using an LED electrical appliance. You could just say a little red highlight on a television. Okay, guys. So hope that makes sense. Any questions, be sure to ask me. Okay, guys.